So far, all of our independent variables have been continuous, but there are times when we want to be able to bring in a categorical variable. And this is quite easily accomplished simply by encoding it. So in the simplest case, we would have a categorical independent variable with only two levels. Um, and so there are plenty of variables that have this kind of binary structure where it's just a yes or no, an on or an off, male, female. So these are things that we can just put in a 0 or a 1. So cases in business are things like, you know, has bought the product previously versus they haven't, or they have left the company previously versus they haven't. So there are plenty of cases where we have what's a categorical variable with only two levels, and we just say, arbitrarily, one of them is 0 and one of them is 1. Okay. And we can put this into the regression with this kind of coding. So what we'll have then is a model that would look like this. So instead of what we had before, which in the simple linear regression was just these two. So, now we have a multiple regression case here where this second variable can only take on a 0 or a 1. Okay, so in this case, what we're doing is we're going to use our old example of pie sales. We're going to try to predict pie sales. And once again, our x1 variable is going to be price. And we've seen this coefficient estimated before. And now this second variable is going to indicate whether or not it was a holiday or if a holiday occurred during that week. So it's going to be a 1 if there was a holiday, and a 0 if there was no holiday. Okay, so quite an easy encoding. And let's go ahead and do that, and then talk about, on a theoretical level, what happened to those lines in the regression. Okay, so we've got our good old pi data here, and let's see. We just want to do price and whether there was a holiday. And just to make things easier, I'm just going to, to make the selection easier, I'm going to move this this row over here. Insert cut cells. Okay, because I want to be able to select these two. Okay, so let's go back to data and data analysis, and we're going to do regression again. So all right, so our dependent variable is going to be pie sales, and our input x, we're going to bring in both the price and whether there was a holiday. So simply a 0 if there's no holiday, a 1 if there was a holiday that week. Okay, and we'll keep the labels, and we'll go ahead and just put it in a new worksheet. Okay, so what we see is that we have a pretty good model here. We've got nearly 50% of variation explained, with our adjusted R squared, and we've got a significant amount of variance explained in the ANOVA, and so down here are our parameter estimates. We can see that the holiday variable is significant, to more than 95% confidence level, and price is only significant, at the 10% level. But let's think about what these, interpreting these coefficients now. The dummy variable of holiday has a similar interpretation. The only trick is we have to remember what a 0 means versus a 1. So like in price then, so this was our continuous variable, and we interpreted this coefficient, and we'll assume that it's significant to our interest, that we're okay with this 90% confidence level. So that means for every $1 increase in price, we can expect sales to go down by 19. Okay. And what this coefficient is going to mean then is that um, that for every 1 unit increase in that holiday variable, we can expect 74.89 increase in sales. So what does that mean? That means that on weeks where there was a holiday, we sold 75 more pies than on weeks when there was not a holiday. Okay. All right. So, but let's think about what it means when a variable only has two levels. It's only got it can only be a 0 or a 1. Our estimate of that, of our case, the pie sales, is going to be, we've got that intercept, and then we've got our continuous x variable here, and then this is the estimate that would result when this holiday variable is equal to 1, right? So it's just multiplying this estimate by 1, okay? So if that's the case, then we don't really need to even put x2 in there because it's just going to be a 1. And we wind up, so this just winds up being a constant term. And with constant terms, you can collect them. So we've got this now is just one other constant. And the estimate is then just going to be this plus this, plus this figure, this expression right here. Okay. Now, what this part of the equation is the intercept. Okay. Now, in the case where the dummy variable is 0, that means this entire thing just goes away. So the estimate is actually just going to be, the intercept plus that. Okay. So look what we have here. So both of these have the same, this part is the same. So the part that's actually multiplied by the, this price variable is the same, but what happens is we're adding a different constant. Now what that means is that we have two lines here with two different intercepts. Okay, so this is one intercept and this is another intercept. Okay, so this line here where it's not a holiday is here, and this line here where it is a holiday is above this line by this amount, right? So we're adding that B2 there to that intercept. So this distance, this difference here between this line and this line is just B2. So that means for a given, for a given price, let's say, we've got this particular price right here, then we'll say if it's not a holiday, this will be the price right here. But if it is a holiday, it'll be that plus this quantity, this B2. Okay, so then that B2, this B2 can be interpreted as the difference in the dependent variable between I'm sorry that's so sloppy, between 0 and 1. Okay, so that's how much you can add to the pie sales if it is a holiday. Okay, and that's spelled out here more explicitly. So okay, so we've got this sales equation here. This is the intercept, the overall intercept, so that's our B0, and then it's going to be this. So this is going to be our B1, and then this price was our X1 variable, and then this is that B2, and then this is going to be either a 0 or a 1. Okay, so this B2 is going to be that. What this means is that when there's a holiday, you can expect an increase of sales of 74.89. Okay. Now, what if we have a categorical variable that has more than two levels? Okay, we can't do 0 and 1 if we have, let's say, Democrat, Republican, and Independent. So now we have three different levels of a categorical variable. Well, what do we do in this case? Well, we can still do this trick of encoding things as zeros and ones, but we just have to create new variables. So let's take a look at an example here. So let's say we're interested in spring, summer, fall, and winter. Okay, so this is actually one categorical variable with 4 levels. Okay, so how do we put this into a regression? Well, we could, and this is where we'll start. We'll start by creating 4 new binary variables. Okay, we'll call them spring, summer, fall, and winter. And then all we have to do is just put in, a 1 under spring if the row took place in spring, and a 0 for the other ones. Okay, so the spring row would have a 1 here, the summer row would have a 1 here, and zeros everywhere else. Okay, the fall row would have zeros everywhere except for the fall row, and the winter row has zeros everywhere except for the winter row. Okay, so we just have these ones here, and so that way we will be able to determine, okay, so the coefficient, say on the spring variable would tell us what is the additional, what is the increment in the dependent variable that's due to the fact that it took place in spring. Okay, but the problem with doing it this way is that we now have that multicollinearity. Okay, and the reason why we have multicollinearity is because if it's possible to predict one variable, so if we know, let's say that this winter row has a 0 here for this variable, and a 0 for this variable, and a 0 for this variable, we can, with 100% accuracy, predict the value of that other variable, which means that we have the problem of multicollinearity. Okay, so if it's possible to put some combination of other variables together and predict with 100% accuracy another variable, then you're going to have that multicollinearity problem, and you can't really do a regression this way. Okay, so how do we get around this? Well, we can create 3 variables and then just designate the 4th variable as the 4th level as a reference level where all 3 is equal to 0. Okay, so here's an example. So instead of doing that, we say, okay, we want to compare everything to winter. So this will be our reference level. Okay, our reference level. And we're just gonna chop that off. Okay, and we wind up with this. Okay, so now we've only got three new variables, and we've designated winter as our reference level. Okay, so now notice that this still gives us what we want. Okay, this still gives us what we want because we can tell what season a row fell into simply by the values that are here. So for example, like before, the spring row is going to have a 1 here and then zeros here. Summer will have a 1 here and zeros here. Fall row has a 1 here and zeros here. But this time the winter row is going to have zeros in all of them. Okay, so if it's not spring, it's not summer, and it's not fall, then we say, well, this is winter. Okay, so our estimate then, so if we're going to predict sales, okay, using our pi example again, we're going to have that intercept plus that continuous variable times its coefficient plus, okay, here's this holiday dummy variable, which is 0 or 1, okay, Now we've got these seasons in here. So spring is going to be 0 or 1. Summer is going to be 0 or 1. And fall is going to be 0 or 1. Okay, so in that case then, the shortened version of this, if it's winter, so if it's winter, that means this is 0, so that falls out. That's 0, that falls out. That's 0, that falls out. So we're just left with this part. Okay, so this is why sometimes winter is called the base level. So this is the if we don't have any ones for any of these other ones, then we know that it is winter. So therefore, to predict the sales in winter, we only have this part. Okay, and then we can interpret each of these with respect to the base level. Okay, so that means that the estimate of B3 is going to be the sales difference between spring and winter. Okay, and B4 is going to be the difference between summer and winter. Okay, and B5 is going to be the sales difference. Actually, that's not finished. So B5 would be the difference between fall and winter. Okay. All right. So basically what's going to happen is these are going to tell you, okay, how much can we expect sales to change when it's in spring or when it's in summer or when it's in fall. Okay. So we just have to create dummy variables in this way, where we have one fewer variables than we have levels of that categorical variable. Okay, so let's take a look at an example, and you'll see more of this sort of thing when we do forecasting later. I've got data here, and incidentally, this is actual real data. This is revenue for Walmart. Based on quarters. Okay, so we've got first quarter of 2008, second quarter, third quarter, fourth quarter, etc. Okay, so this is the year divided up into quarters, and this is the revenue for that particular quarter. And this variable is the ad expenditures in millions. So this is going to be revenue in billions, and this is ad expenditures in millions. Okay. And so what I've done over here is I've created dummy variables for the quarters. So we see this is, first quarter. That means there'll be a 1 there and zeros there. This is a second quarter here in the second row, which means there'll be a 1 there. And third quarter means that there's a 1 there. And so that would mean that in fourth quarter, we'd have 0, 0, 0. Okay, so why did I choose the fourth quarter to be the reference level or the base level? Just because in retail, it's very common to have a lot more sales in the fourth quarter than in the other quarters, just because of holiday shopping and so forth. So we want to know what's the revenue in comparison to the fourth quarter. Okay, so let's go ahead and do the regression then with all of these, with this continuous variable and each of these 3 dummy variables here. Okay, so I'll do data analysis again. Okay, and I'm trying to predict revenue. Okay, and my x's now are going to be all of this. Okay, so let's take a look. All right, we've got an adjusted R square here of 0.68. Okay, this is pretty good. So we can predict revenue. 68% of the variance in revenue we've predicted. Very high F with a very low p-value, so that's great. So let's go ahead and provide some interpretations for what we have down here. So the p-value for ads. Okay, so ads right here. Okay, we see that the p-value is very small. Okay, So we can say, okay, the coefficient is 0.65. So this would mean that for every 1 million increase in ad expenditures, we can expect revenue to increase by 0.65. Okay. All right, so let's take a look at these others now. This is, it looks like, well, let's take a look at this one first. Okay, so quarter one. So quarter one, we don't have significance at the 95% confidence level. Okay, but let's just say 90% is good enough. So what this coefficient here means is that if it is a first quarter, we can adjust our prediction down by 7.5, okay? In comparison to the base case, which is quarter four, okay? Now, what about quarter two? So once again, not significance to the 95% confidence level, but okay at the 90%. This means that if it's a quarter two, we can adjust our prediction down by 6.2, okay? And here we see that this is not even close to being significant. So what does that mean? Well, that would mean that quarter three is not significantly different from quarter four, okay? So these tell you the difference between that particular quarter and the base case, which is quarter four, okay? So if I were to ask you a question, if the predicted revenue for a fourth quarter is 80, how much less would that prediction be if it was a second quarter, and it would just be 6.24 lower, okay? All right, so as I said, we're going to see more of this. We're going to actually apply these equations. So maybe just for completion, I'm going to put down the prediction equation here. So to predict, we're going to do, our prediction is going to wind up, our revenue prediction is going to be 68.22 plus 0.65 times ads plus negative 7.51 times Q1 plus negative 6.24 times Q2. And remember, these would all be zeros if it's a winter quarter. Plus, and we'll just go ahead and include it, minus 4.54 times Q3. Okay, these would be your predictions. And if it's a fourth quarter, then you just ignore those last three variables. Okay? All right, so that's how dummy variables work.